So welcome to Electronics CCLA and you are watching Signal System lecture series. And today the topic of discussion is the linear versus non-linear systems. Okay. So we'll see whether how to calculate the following systems are linear or non-linear system. So a linear system actually obeys the superposition theorem. Okay. So any system that obeys the superposition theorem is known as a linear system. Otherwise, it is the non-linear system. So let us see how to identify the for the systems are linear or non-linear systems. Okay. So there are a general class of system that is classified into linear system or non-linear systems. A linear system, as I have told you, the one that satisfies the superposition principle. Okay. So if the superposition, what is the superposition principle? So it applies the response of the system to the weighted sum of the signals. Okay, is equal to the individual weighted sum of the responses. Okay, of the individual signals. Okay. So weighted sum of the signals means is equal to the weighted sum of the responses of the system to each of the individual input signals. Okay. So let us see how it means. Okay. So a relaxed system means the any LTI system. So prior to the applying the input, the system output will be 0. Okay. So any relaxed system is linear if n or if. So transformation of a1 x1 x plus a2 x2 n equal to a1 into t of x1 of n into a2 into t of x2 n. So this is actually that we have means that is the this is the called the response of the system to the weighted sum of the signals. Okay, and this is called the means corresponding individual input signal. So we are calculating the individual input. You can see the individual input signals. We can transformation of the individual input signal. Then we are applying the weights. Okay, this is also the x1 and x2 are the where actually calculating a response based on the x1 and x2. Then we are applying the weights. But in this case, the response actually the weighted sum of the signals. So this is already the weighted sum of the signal. Weighted sum of the signal. So total is a1 x1 of n and x2 x2 of n is applied to the system. In this case, we are applying x1 of n, then we are applying x2 n, then we are multiplying the weights, then we'll sum it up. Okay. So if this two equal means this equation is equal means then it is called the superposition theorem is applicable. Okay. So this x1 of n are the any arbitrary input sequences. These are the discrete time sequences, and arbitrary constants are a1 and a2. Okay. So let us see that in terms of a diagram. You can see this one is your x1 of n and x2 of n and a1 a2 applied to the system. Okay. So this output is your a1 x1 of n, okay, plus a2 x2 of n. So this is applied to the system. This is a discrete time system. Okay. So this discrete time system, the output will be transformation of a1 x1 n plus a2 x2 n. Okay. This output. Okay. Similarly, this one is here we are applying individual input signal. So this is the transformation of the output will be transformation of x1 of n. Okay. Then it is multiplied by a1. Similarly, this is a2 transformation of x2 of n. Okay. So if these two are equal, means this is y prime n. So this is a1 t x1 of n plus a2 t transformation, that is the x2 of n. So these two are equal, then it is called as the linear system. Okay. So let us check that is some questions. Okay. So determine the system described by the following input output equations are linear or non-linear. Okay. So there are three questions are there. So y of n equal to nx1, then x n square, then x square n. Let us see that the first one is your y of n equal to n into x1. Okay. X of n. Okay. So here first what we are doing that input sequence are x1 and x2. So let us apply the input sequences x1n and x2n. So y of n equal to first is the transformation of x1 and n. So this will be n into x1 of n. Similarly, transformation of x2 of n. This will be n into x2 of n. Then we multiply a1 and a2. Okay. So the output this is the right hand side actually of this equation. So then we are applying weighted sum of the all the signals. a1 x1 of n plus a2 x2 of n. So it will be n. So in place of x of n, we are putting this a1 x1 of n plus a2 x2 of n. So it will be a1 of n, x2 of n, a2 of n, x2 of n. Okay. So now this linear combinations of the two inputs. So a1 y1 of n plus a2 y2 of n. So what is y1 of n? This is y of n. Okay. So n into x1 of n, then a2 n into x2 of n. So this is our equation 2. So you can see both equations are same. I think both equations are same. So superposition theorem satisfied. Therefore, the given system is linear. Okay. So here what we are doing is that, so we are given with n into x of n. Okay. So first we are applying this x1 of n. Okay. So in place of x1, what we are doing, we are applying x1 of n. So that will be n into x1 of n. Similarly, in place of x of n, it is x2 of n. So that is, and it is n into x2 of n. Okay. So then this system is a1 y1 of n, linear combination of that n, it will be plus a2 y2 of n. So it will be a1 x1 n into x1, then a2 n into x2. Okay. So this is your equation 2. In equation 1, we are applying this a1 x1 and weighted sum of the means inputs. So a1 x1 n plus a2 x2 n. Okay. So in place of x of n, we are applying this. Okay. So that will be this one. So in this case, the both equations are same. That is why the system is linear. Okay. Let us check our second case, x of n square. So you can see the response of the system to separate input first. So y1 of n equal to transformation of x1 of n. So in place of x, we are applying, we are putting x1. Okay, so x1 of n square. Similarly, x2 in place of x, we are putting x2. So x2 of n square. Okay, so this is the individual weighted, individual. Okay, then we can individual responses. Okay, then we are means we can means multiply a1 and a2 over here. Okay, so the output, this is the same, means weighted sum of the all the input signals we are applying. Okay, so a1 x1 of n and a2 x2 n. So in place of x, we are applying, that is the a1 x1 and a2 x2. So this is the a1 x1 n square plus a2 x2 n square. You can see this both linear combination of the two in output. So a1 y1 equal to this one, then y2 equal to x2 of n square. Okay, so this equation 1 and equation 2, you can see both are same. Okay, so that is why the system is linear. The superposition theorem is applied. Okay, applicable. Okay, third case, you can see x square of n. So this is the response of the system to the two separate input sequence. So x1 of n, transformation of x1 of n, so it will be x1 square. Okay, similar transformation of x2 of n, it will be x2 square n. Okay, so now the weighted sum of the means inputs, so it will be a1 x1 plus a2, so this will be we can replace x by this one, this whole term, so that will be square. Okay, that is a square. Okay, so in this case, you can see the linear combinations of the two inputs a1 y1 y of 1 this one and y2 and so a2 x2 square. So equation 1 and equation 2 actually not equal. Okay, that is why the system is non-linear. Okay, the superposition theory is not satisfied. Okay, so that's the about linear and nonlinear system. So what we are doing is that, so first we are a1 x1, this is the a1 x1 n plus a2 x2 n. Okay, a2 x1 if this is transformation of this one. Okay, then is equal to transformation of a1 transformation of x1 of n plus a2 transformation of x2. If this is equal, then it is a linear. So how to calculate this one? So simply you are replacing this x, okay, by this whole thing a1 x1 of n plus a2 x2 of n. In this case, we are also replacing x with x1 of n first, then x2 of n. Then we are multiplying a1 a2. Okay, in this case, the whole things a1 x1 of n plus a2 x2 of n we are replacing with x. In this case, also we are replacing x with x1 of n, then we are multiplying. Here also we are replacing x with x2 of n, then multiplying by a2. Okay, then sum it up. If both are equal, then the system is linear system. Okay, so this is how to means difference between linear and nonlinear system. So thank you all. So have a nice day. Thank you for watching this video. If you have any doubt, please free to ask me in the comment section. Okay, thank you all.